Okay guys, so let's just proceed with the last example of second order. So let's say you are given this function, this equation, y double prime minus 6y prime plus 9y is equals to t squared exponent 3t, with the condition y0 is equals to 2, y prime 0 is equals to 6. Okay, so the first step is by applying Laplace operator. So Laplace of y double prime minus 6 Laplace of y prime plus 9 Laplace of y is equals to Laplace of t squared exponent 3t. So here y double prime is equals to s squared ys minus sy0 minus y prime 0 minus 6. So y prime is equals to sys minus y0, and the last one is plus 9ys is equals to, so take a look at the function on your right hand side here. You cannot get the Laplace of this one directly from the table. So please try to do on your own here, and you should end up with this one, 2 over s minus 3 cube. So you can either use first shift or multiplying by Tn. So try to do, and please make sure you get this answer. If you cannot get this answer, and go back to the previous video on how to find this one by using first shift or multiplying by Tn function. Okay, so expand the whole expression here. So you will have s squared ys minus sy0 minus y prime 0 minus 6sys. So minus minus will give you plus 6y0 plus 9ys is equals to 2 over s minus 3 cube. Okay, so apply condition. Y0 is equals to 2, y prime 0 is equals to 6. So you will have y0 is equals to 2, so here you will have 2s. Okay, y prime 0 is equals to 6. Y0 is equals to 2. So 6 need to multiply by 2. Okay, so you will have s squared ys minus 2s minus 6 minus 6s ys plus 12 plus 9ys is equals to 2 over s minus 3 cube. So step number 3. So remember, before you can factorize your ys, you need to move this one, and also this one to the right hand side. Okay, so therefore you will have s squared ys minus 6s ys plus 9ys is equals to 2 over s minus 3 cube plus 2s. So minus 6, so here you will have plus 6, minus 12 will be plus 12 will be minus 12. So minus 12 plus 6 will remain minus 6. Okay, so factorize your ys. S squared minus 6s plus 9 is equals to 2 over s minus 3 cube plus 2s minus 6. Okay. If you want to do something so that it will become one function, it might take time and difficult for you. Why? Because you have power 3 here, not square. Okay, so I will just remain as this one. Okay, so therefore your ys is equals to, so each of these function need to be divided by this one. So the first one will be 2 over s minus 3 cube s squared minus 6s plus 9 plus 2s over s squared minus 6s plus 9 minus 6 over s squared minus 6s plus 9. So as you can see here, all this function you cannot get directly from the table. So clearly you need to apply partial fraction. But take a look at the quadratic function here. Before you proceed with the partial fraction, it will be ridiculous because you need to do 3 partial fraction. This one, and this one, isn't it? So try to think a little bit on how to simplify this one. So as you can see here, you have a quadratic function s squared minus 6s plus 9. Remember, I told you before you want to proceed with the partial fraction, if you have a quadratic function, you need to factorize if possible. So let's try to factorize this one. Equation degree 2. So your A is equals to 1, your B is equals to negative 6, and your C is equals to 9. So as you can see here, you can factorize it. Okay, your x is equals to 3. So you just have one value, which means you have a repeated value here. So if you have x is equals to 3, so the factor will be x minus 3. So in this case, s minus 3. The whole thing squared because you have the same value. Okay, you just have one value right here. So when you have s squared minus 6s plus 9, so this one is equals to s minus 3 squared. If you expand, you will have this one. So now try to replace the quadratic function, this one, with this one. So now your ys will be 2 over, so as you can see here, for the first function, you already have s minus 3, but this one to the power of 3. Okay, so you have s minus 3 to the power of 3, and another one is s minus 3 to the power of 2. So the second one will be 2s over s minus 3 squared. And the last one is minus 6 over s minus 3 squared. Okay, so this one, remember, if this one multiply, then power we need to add. Okay, so therefore you will have your ys is equals to 2 over s minus 3 power 5 plus 2s over s minus 3 squared minus 6 over s minus 3 squared. So take a look at your YS now. Do you really need to do partial fraction? If you want to proceed with the partial fraction, then you are in trouble. Why? Because you have 5 here. Repeated linear with power 5. So you will have A, B, C, D, E. Isn't it? For one function. And another one is A and B. For this one is another partial fraction. And the last partial fraction will be A and B also, if you want to proceed with partial fraction. But as you can see here, you can apply other properties for you to get the inverse of this one. What is that properties? Try to think. Okay, so the inverse of this one, so inverse of ys is equals to, so 2 is a constant, so inverse of 1 over s minus 3 power 5 plus 2 inverse of s over s minus 3 squared plus 6 inverse of 1 over s minus 3 squared. So I really hope you can get the idea on how to get the inverse of this one. So basically you can just get the inverse of this one by using first shift properties. Okay, because you have s minus e term here, so this is the first case. This one s minus a, and you have s here, so this is second case. So this one is s minus a again with the power of n is equals to 2, so this is the first case. So you need 3 first shift properties. So try to solve this one separately and combine the answer. Okay, so that your last answer will be, so this is step 4. So step 5, your yt should be 1 over 12 t power 4 exponent 3t plus 2 exponent 3t. So please try to do on your own. Apply first shift properties of inverse Laplace transform and get this answer. If you can solve this one, and for sure you already understand that properties. Okay, so please try to do on your own until you get this answer. So basically we are done with chapter 4. Okay, so let us recall back on what we had learned in this chapter. So the first part is I teach you on how to get the Laplace from ft to get your fs by using Laplace transform, and we also learn the properties. So please just ignore this one, okay, because we don't learn this one. Okay, so just ignore the first one. Okay, so the first thing that I teach you in this chapter is on how to get the Laplace transform from ft to fs by using table, right? So the second one is properties of Laplace transform. You have linearity, first shift, and also multiplying by Tn function. The next one I introduce to you inverse Laplace transform, which is from Fs to get your Ft directly from the table by using inverse operator here. And we also covered properties of inverse Laplace transform, which is linearity, first shift, and also inverse Laplace transform of rational function. And today we done with this one, solving first order and second order linear differential equation by using Laplace transform. So we are done with chapter 4. So please try to proceed with the exercise for first order and second order, and if you have any problem, please get to me either by using WhatsApp or at Moodle. Okay, so for my next class we will proceed with the last chapter, which is chapter 5, Fourier series. So I shall see you in my next video. Thank you for your attention. So thank you. Assalamualaikum.